Today we're going to be hearing from Cherisse Du Preez, who is the head of the Deep-sea Ecology Program for Fisheries and Oceans Canada. She also is an adjunct at UVic up there in British Columbia, and is co-founder and lead of, I'm going to call it NEPDEP. And so we're really excited to hear about her lessons learned from the Northeast Pacific Deep Sea Exploration Program. And I'm going to stop sharing and hand it over to you, Cherisse.
And you are muted, Cherisse.
How's that?
That's good.
Okay, great. Julie, I hate to call you out on a mispronunciation, especially since I'm going to butcher every science word I try to say in this talk, but it's NEPDEP. It's supposed to sound like a robot because I think it's fun, and all my co-founders tell me that I'm saying it wrong, but when you invent the acronym, I think you get to decide how it's said. So, yeah. Okay, so Cherisse Du Preez, I'm really excited about this talk because I just made it and I haven't tried it out yet. So I hope you enjoy it as much as I enjoyed making it. I'm just going to fly straight into it. Let's see. Okay, briefly, all you really need to know about me in a nutshell is that I love the ocean. My job apparently is to collect a lot of letters and make an alphabet soup out of them on account of wearing a lot of hats that go with a lot of acronyms. The main acronym that is most important for today is that I am the head of the Deep-sea Ecology Program. If I move my mouse around, can you see it?
I don't see it right now.
Oh, shoot.
Oh, barely, a little bit, yes. Just keep moving it around.
You can see it when I move it on this screen, but maybe not on this screen?
Correct.
Yeah. Ooh, that'll be interesting. Okay, let's just go with it. Okay, job aside, personality aside, I think for listening to me for the next 30 minutes, I should disclose that I am severely dyslexic and my brain, or actually this might be a real picture of my brain, it likes to bust through lines and try find the magic and smushing things. So what I wanted to do was structure this talk by telling you 3 stories that I think actually it helps to cross lines and barriers, and that I would wager that the magic and our understanding of the natural world really comes from when nothing seems to make sense and everything's interwoven, which is a great get out of jail free card when your science just isn't working out. But we'll leave it at that, and we'll maybe revisit that at the end. Did things not work out, or is everything just as planned? Okay, the first line of stories is thinking outside of the box. This is the boundaries in which I work in, the Pacific coast of Canada, and I was hired in 2017 to go and look at the deep sea and find places to protect. So your job, federal scientist, go to deep sea, protect things for Canada. Okay, straight away, the boundaries I'm given don't feel right, because that's not really Canada. This is Canada. Canada is a nation of nations. So when I say I work for Canadians or the public, I actually work for many nations within Canada. And so straight away, day one of my job doesn't feel right to do my job. And so we start going outside of the boundaries. It turns out that in the coming years, I'm actually, in for quite a lot in the deep sea. We have Scone Kingless Bowie MPA to the north, and that's co-managed with the Haida Nation. So Canada and the Haida Nation. Then south of that, we have an incredibly large marine protected area in the deep sea, Tanguan Hachquika Sea Geese. That's the Haida Nation, the Pachidat, the Nuchalnath, and the Quatsino. Then we also have coastal in the fjords. That's a lot with Sakura. So that's the Helsik, the Kitasoo, the Hay nations. So this is just kind of the playing field. And the people that, instead of just working for the federal government of Canada, really work with and for these other nations too. If you've seen any of my stuff on social media, you'll know that a big part of what we do is going out to sea as a team, the nations all together, a lot of early career scientists, a lot of students, and we explore. And in doing so, we do capacity building. We do a lot of stuff online into the communities. So I could give an entire talk on that, but that's not what I'm going to talk about. I'm going to talk about like a bunch of examples that explore how things are better when you cross these lines. And they're almost like lessons learned. If you're going to go out and do science similar, these are the things that I've learned that have worked. So the first example I wanted to talk about was the central coast of Canada. It's also known as the Great Bear Rainforest. And we started going there not because the federal government wanted to, but because of the coastal First Nations. The guardians of these waterways have been exploring the areas for decades, and all the way down to 200 meters, they have time series about the corals and the sponges and the rockfish they find there. But they were limited to 200 meters, even though the fjords go much deeper. And so they partnered with us and said, like, bring out the expertise, bring out the equipment. We have a gap that we can't fill. And so we did. We took our drop camera out there and our little Phantom ROV. We all packed onto the Vector and we went out to the fjords. And it was the coastal First Nations that led the publication, the identification of places that were important to them from their data set and from the data we were able to provide. And this initial project went so well that we continued to go back up and through the guidance of the coastal First Nations would go explore areas. And so very recently, we actually went to explore an area where they knew there were a lot of fish. And we found what turned out to be Canada's first living coral reef, the first Canadian coral reef in the Pacific, the most northern coral reef ever documented. And very quickly, we were able to turn that around and make a fishing closure around this. And that actually was just in the news that the federal government and the coastal First Nations decided together to close this. And it's fairly easy to do that when you start the co-creation of science from the beginning. You're on the boat together, you're thinking up the ideas, you're following through, you're streaming everything live. And then there's no convincing people after the fact that it's important they were there or their communities were there live. And it happens quick then. And you can do something like protect a large area in the span of just a year or two. And while that might sound slow to some of you, I'll just remind you again, I work for the federal government. That's insanely fast. That's light speeds. Okay. So the next example isn't exactly deep sea, but we were exploring sea mats when we came across it. And I'm hoping you're going to hear some audio right now. I'd like to introduce you to Itchy Shark.
Probably been silly one. It's about 5 feet in front of our bow.
It's coming right for us now. Right. Is this a salmon shark?
Yes.
So we got a 2-meter male salmon shark.
We were out there deploying a couple of gliders. We noticed that it started brushing itself on this log over and over again.
Whoa.
Right there.
It looked like it was aiming for like these big clumps of barnacles, and then it would heave its body out of the water and actually slide it along.
That is so cool.
Oh, that's where his parasites are. Those are the tags. It's really interesting that these logs out at sea may be scratching posts for them to rid themselves of parasites. We were observing an animal in the wild doing what it naturally does, and it didn't seem to be bothered by us at all. As far as I know, this footage doesn't exist elsewhere.
That's incredible.
Probably been silly one.
So the person in the video with me there is Howell Winanis, and the important thing to note here is that we were in the Tangwan Hutchkrika Sea Geese MPA when this happened, and by his English name, Joshua Watts, he was the research scientist that was on the little boat with me when this shark came. And I could tell you about the science of the shark. We did write it up. But the more important thing is that Josh was on the boat with us, and Josh is also an artist of the Nuchalnath Nation. And so we wanted to write this up together. And Joshua wanted to do a field drawing of what he had seen. And so he did it in the style of the Nuchalnath art, which you could see here. Actually, the picture right behind me too. When we wrote this up, we came into some boundaries or some structures that made it difficult for us to deliver the science in the way that we co-created it. We wanted Joshua's art to be our field note drawing. We wanted Joshua's Indigenous name to be there. And I'll show you in the paper, it's right here. I'm just gonna give you little tidbits. In the coastal First Nations, the first name and the last name isn't. There's two names, but they're both their names. And so think about how we publish and how it goes into databases where your first name becomes just a letter and your last name is what it's known by. But that's not how it is in all cultures. So to get this published, we actually had to bounce around between journals. Some journals did not want to take this route. Some journals actually offended us in their replies. So as the scientist who could say no, we turned around and said no to the boundaries that they were imposing on us. And we found a journal that would publish it the way that we wanted to, using Unicode for the names so that the text didn't get edited when people copy and paste it, using Joshua Watts' preferred name, using the art that we provided. And when we found the journal that would go for it, they went for it in such a big way and they celebrated it so much that they actually made it the cover of that issue. And so the authentic inclusion and visibility of the Nuchalnath in this piece of science was very important to us. And it took a little while. I think if Heidi's on this call, she might be able to correct me, but I think it took us like 1.5 years to find the journal who would do right by the science. And it was worth every minute that we waited. The other thing that bringing art and science together is that we took this experience and it was transformed into the Nuchalnath space. And so Joshua got to share his experience in other places other than just speaking to scientists. Don't get me wrong, I love speaking to scientists, but it went into art, it went into the community, and then they got to have a discussion about a marine system that otherwise wouldn't have happened. This also appeared on Nat Geo and Discovery Channel, and I'm not going to show you the pictures right now because it's a little embarrassing, but it actually was featured on an episode of Sharks Gone Wild, which is not my crowning achievement as a scientist, but at least worth noting. Important to get science into lots of different places. Okay, so the third example is about working with coastal First Nations, thinking outside of the box and thinking about names and history. So sometimes I actually do have to write formal federal reports, but thankfully I'm doing so with the co-managing First Nations now. So the example I'm showing you is one that we wrote up for monitoring the deep sea. And instead of it just being Fisheries and Oceans Canada, this was co-created with the Haida Nation. I'm going to point out some things that aren't going to be groundbreaking to you, but if you've ever crossed over into the federal world, you'll realize how groundbreaking this is. But we actually have the Haida Nation logoed on this federal document, which was a fantastic breakthrough and hopefully now the standard, the acknowledgement of it. We've got the icon here and the art for Skan Kingless. While the seamount is incredible and full of diversity and well worth protecting for its ecological value, it's also a cultural and spiritual place, and Skan Kingless is a supernatural being for the Haida, so it acknowledges that. It is a federal document about science and framework, so of course we've got a flow chart that looks like spaghetti, but that's just a box I have to check. And then additionally, and something I'm really happy with is we needed to make a timeline of the environment. And so what's in purple here and actually squished into a very small short timeline is I think what would normally take up the timeline of a timeline, which is when things started happening, like whaling and fishing and exploitation and protection. But we actually try to see this in the timeline of the entire ecosystem and acknowledged when the hydras started to interact with the seamat and their cultural history, and purposefully tried to show in scale how small our history is when theirs goes back 10,000 years to when the seamat was actually an island. Okay, I'm going to try playing another little video here.
An extraordinary discovery unfolded beneath the surface of the waves. Around 1,800 meters deep in a vent field previously thought to be extinct, we discovered a brand new, powerful series of hydrothermal vents. This area was pulsating with vibrant life. I am honored to announce the vent area name, Kwakina, meaning hot rocks in the Haida language. It's a proud moment for Haida Gwaii. We share another deep sea area with a special name to pass on for generations to come.
I love that. So that was Rain Boyko from our expedition last year. And the picture that I flipped to is a multi-beam on the outside of a ship. We don't have a way to map our seafloor on the Pacific coast, so we made a way. Essentially, we don't have a ship that can do it. So we borrowed some equipment from, I think, Norway. Ocean Networks Canada helped us out a lot. We made some super magnets, and we just stuck the multi-beam to the side of the ship because we needed to map the deep sea. And while we were mapping the deep sea, everything we discovered, as you saw in Rain's video, we provide the science so that the coastal First Nations can name them. That's a very important aspect of our work. So here's our multi-beam. Our multi-beam goes in the water. We go running around the ocean and we map the seafloor. And to show you how successful our mapping and looking has gone, in 2016, we knew of 20 seamounts off of our coast. I'll point out that we didn't have very good maps. The little inset here shows you the lines that we actually traveled. This is like a little magic trick that maps in the deep sea do. They all fill in with blue, so you think they're mapped. But as many of us know, we actually haven't done a very good job mapping the deep sea. That's very much the case in Canada. So when we went and filled in some of the gaps, right now we're up to 65 seamounts and counting. And all of those are in the process of getting named by the coastal First Nations. So UNTREP is very important to us, celebrating the International Decade of Indigenous Language, very important to us. Things that needed to be done for this to be the case, because if you're anything like me, this feels right. This is just the right thing to do. Problem is you can't submit science without a name, and the name has to be permanent. So we had to go in and start changing fundamentally the way that names were processed into the database so that they could be stored. Because one part of decolonizing science is to stop the timelines that we enforce, to give space and time for the communities to do things the way they want to process them. And so we actually managed to work with the advisory committee on undersea feature names. And as of right now, we actually have all the science in place. We have placeholders for all the names, and on their own time, the coastal First Nations can provide the permanent names. And so that brings me to NEPDEP, which is actually the placeholder for all these seamounts. I really look forward to, because of the names, they're wonderful to learn how to say, and they also they have incredible meaning. So this brings me to the first thing I did not expect to do in my job, which is I did not expect to create NEPDEP. We were just following our feet and doing the next thing that needed to be done or felt like it needed to be done. And we've been doing this for a few years now. And then very recently, our expeditions, we started working with Challenger 150 and the Ocean Decade, and it just evolved that the next step, what felt right was to get us all on an even playing field. And so now the Haida Nation as a main partner, Fisheries and Oceans Canada, the Chalmers Ocean Networks Canada, the Royal BC Museum, and UVic are the main partners that created NEPDEP, this program that we could explore the deep sea together and do things at that even level. And it's been incredibly rewarding, but just unexpected. And then very recently, we became an Ocean Decade project, which is really fun. So I look forward to several years of doing this, and probably just forever, because again, it's just doing the next right thing. And yeah, but now we have a name for it and a cool acronym. I forgot to check my timer because I actually have a fair bit to say. I've clocked that I've talked for 17 minutes. Rosalind, can you, I don't want to like speed up too fast. Can you confirm how long I've been talking for?
I think you have time to continue. I haven't been keeping track.
Okay. I feel like I'm halfway through, but if anyone needs to tell me to speed up, just speak up and I will. But I'll leave the recap of thinking outside of the box as just a slide for now. And if people want to go back to it or when they watch the YouTube. Okay, so that was actually one storyline, and it was the biggest one, but it's the biggest thing that I didn't expect to do with my job. The next storyline about boundaries and lines is if you're given a structure, beware of blind spots. And I'm going to go through this hoping that everybody here has watched the COBRA talk on the deep sea and deep sea mining, but this one has to do with deep sea mining. So one of the hats I wear is as a Canadian delegate to the International Seabed Authority. And I'm going to walk you through the structure that I was introduced in 2020 when I first started going to these meetings. That's that science contributes to the ISA to a region. Okay, so there's many regions, but my region that I work on is the Northwest Pacific. Then there's an ecosystem, your nodules, vents, or seamounts. Well, I'm seamounts. And then there's a theme within the workshop meetings. Are you cumulative impacts or are you spatial management? And I was spatial management. So great, I have a home. And in 2020, I worked really hard to provide science advice to this end. And immediately what jumped out was that there is no seamount inventory for the Northwest Pacific. And that seemed like a huge oversight. And so I spent most of that workshop coming up with a way to map and index those seamounts. Found out there was like 205 seamounts there, that although it seems like a lot, the shallow parts of the seamounts actually only represent 4.3% of the seafloor. So that's areas above 3,000 meters. So this is the blind spot that I'm going to tell you about. 40 to 70% of those habitats that are shallower than 3,000 meters are already contracted. I say 40 to 70 because we did depth bands and we're like, we don't want to treat it all the same. So let's talk about habitat types and representativity. So that makes it already nearly impossible to get to 30% protection for some of these if you're focusing on representativity. And that's even worse if you are looking at just the seamounts that hit the sunlit summits. So that seemed like, wow, that's the biggest thing that I will ever find out for the ISA. Like they're going to take that and run with it. I wish that was the case, but that's not actually the case. But okay, let's fast forward to just a few months ago. We have another workshop for this region. And now I'm starting to pick my head up. So are the other scientists that are there. And we're like, well, what did we miss by getting pigeonholed? And so I'm going to work backwards here. And if you remember, the theme I told you I was in was spatial management. Well, as soon as we crossed over and started sending some of the scientists to the cumulative impacts, it came out pretty quickly that climate change wasn't really considered. So climate change wasn't considered and the impacts are going to get to this area. I'm going to go through these pretty fast, but hopefully if you think climate change wasn't considered, that jumps out as you as a blind spot. This is my favorite part is the nodules. I didn't think about nodules. I was like, Diva and Beth and people like Animataxis have nodules under control. I'm going to focus on seamounts. Well, at the workshop just a few months ago, we've revisited the areas that we proposed in 2020, which is the map I have up there now. And the arrows that I'm pointing to are the protected areas that we proposed for nodules. We proposed, some of us weren't really paying attention to nodules though. And some stuff struck me as weird, especially when Anna Colosso asked, is there any nodule data that we can use to make sure that these are right? To which the ISA turned around and said, no, there's no nodule data from the contractors, can't be shared. So we had no data. So this is us just a few months ago thinking, how are we going to check for this? The other thing that occurred to me was in creating a map that I was working on at the time to do with the seamounts. The seamounts are the colored patches. Their symbology doesn't matter for this, but I overlaid it, the nodule contract areas, which I'm moving my mouse to point out to you, but you can't see it. Let me try this one. There, these are the nodule contract areas, okay? These are the seamounts. And as soon as you make this transparent, it's like, well, wait a second, the seamounts actually are in the nodule contract areas. This requires further investigation. So I also didn't like that there was no data. So that night I went back to the hotel and I found something on the order of 10 publicly available pieces of data to which I matched. By the next day, I'd found over 200. Now we're actually starting to get presence absence of nodules, and we can use that, or I did use that to build a model in real time based on simplistic things like depth. I think slope was in there, but what's the other thing? Oh, amazingly, there actually was a paper that was already published on this, but an index of how close you are to seamounts. Now, the paper was published as a recommendation of how to find places to mine, but it's like if you could find nodules to mine, you could find nodules to protect. So I created this kernel density for seamounts and then map that on top of depths you would expect to find them. And that's what you're seeing here on the map. Some of the layers are in green and orange, and then the stars are yellow when it's present and red if it's absent. And all you really have to know about this map is that where you see the biggest mess is where you would expect to find nodules. I'm going to point out here that these blocks are some of the MPAs, proposed MPAs, to protect nodules that were created 4 years before. So in the span of about 48 hours, we pretty quickly figured out that while we were paying attention to seamounts, something had gone horribly wrong with nodules. So that allowed us to move forward pretty unanimously as a group that we had missed it. And so we ended that ISA meeting with a proposed location for potential protection that falls in the middle of the seamounts. And then the step beyond that, so thinking completely outside the structure, we all started talking about what was happening in the CCZ, because what was pushed back about the new protected areas we had suggested was that they came into close contact with the places that are going to be mined. And so we started asking questions about the CCZ, which is the map you could see here, and the buffer that it requires. And although this is the part of the meeting that kind of did not get answered, there was this tension between the scientists and the contractors of how close can you get. And this did bring us to a really interesting, pretty obvious finding, which is the CCZ is flat. I'm laughing because I hope a bunch of you are like, that's not really remarkable, Cherisse. The North Pacific, where nodule mining is proposed to happen, where the regulations for nodule mining might be just carbon copied over, it is not flat. So I made these two pictures here, same angle, same elevation, exaggeration, one of the CCZ and one of the North Pacific. And what you're looking at there at the North Pacific is 6 kilometer high seamounts with the mining contract areas shadowed over it. And the elevation difference between where you might protect or where you might mine and the representative area, there's kilometers between them, and this is stratified water. And so I've started to show these pictures to which people are like, oh, it's different. And I'm like, you know what? That's enough. It is different. And we should think about what that means when we go down these routes of structuring. You know, I did it. I focused on Northwest Pacific, CMATs, and spatial management. And look what happens when you start to look at the blind spots that just agreeing to work in a certain structure created. Okay. So this is my summary slide for this too. I'm going to skip over it, but I should just say the last part. I'm not advocating that nobody can deliver structured science. That's not what I'm trying to say. What I'm saying is that if you're going to do structured science, you really have to look beyond the boundaries that you've been assigned to look for the blind spots and see the true nature of the system before you go back into the box you were asked for. And I wish I had done that 4 years ago, but I did that last month now, and I feel a lot better about it. Okay. By my calculations,
You're still doing good on time, Cherisse.
A few more minutes. Oh, yeah. Could you give me an idea of 5 minutes?
Yeah, 5 to 10 minutes is fine.
Okay, fantastic. Thank you. Sorry, I like to start my timer, but it turns out I started it at the beginning of the breakout sessions, and according to it, I've been speaking to it for an hour and a half. So I think that's right. Okay, the third storyline is about generalizations, and I love generalizing. It actually was the first ask I was asked to do at DFO. So we have 4 deep sea EBSs in our region in the Pacific Ocean. We have seamounts, hydrothermal vents, cold seeps, and coral and sponge areas. And I was asked, you know, go out, find them, find representativity, and answer a bunch of questions, whether it's monitoring, whether it's the places to protect, find representativity, find the important places. So I'm going to tell you about seamounts and cold seeps and how I have failed miserably at doing this. I'm going to start with cold seeps. There are no MPAs for cold seeps yet. This is something we're working on. Because of publications that were done before me, I started off with some information. So I showed up at DFO, and there was this amazing report on cold seeps and what you should expect to find at the cold seeps that Canadians have visited. So you got bubbles, you got things like tube worms and chemosynthetic animals, corals and sponge habitat when there's rocks, carbonate rocks, bacteria. Great. I'm going to go out, I'm going to look at some more places, and I'm going to find the important places. Okay, so what is in white here? The white dots are the 5 confirmed cold seeps as of a few years ago. And that's what the generalizations were built on. So great. We found some more. So we've confirmed 7 additional ones. And this wouldn't be in line with my talk if I told you that was the end of the story. They all had just the exact same things, and we've chosen 2 and we're fine. That's not the case. Okay, so we went up to NEPDEP 56, which we actually thought was a seamount. It is such a large mud volcano that it has been mistaken for almost a decade as a seamount. It is, it's 2.2 kilometers high. It's got no carbonate rocks, no chemosynthetic animals. It's like this soupy mud, and every so often there's a carbonate rock. Okay, great. That's not what I expected. We went to Wyona Ridge. Some of these is really great. It's working with Michael Riddell from Geomar, and he's telling us he knows where a plume is, so go check that out. So we went and we checked out Wyona Ridge. We thought that it was going to be a basalt ridge and that maybe we were going to find some methane ice on it because it was the right depth. Instead, we get there and it is a 25-kilometer ridge made out of carbonate rock. It is 500 meters high, and it's like nothing that we've ever seen before. Okay, great. So still not finding representativity and some repeats. We went to Barkley Canyon, which people have gone to for a really long time. And of course, when we get there, we spot something that nobody has ever seen before, which is Barkley Canyon is actually blobbing out hydrocarbon to the surface from 500 meters depth, and it's creating a 1 kilometer oil sheen on the surface. And this is me flying around a drone to document that. Great. Another never before seen thing. Okay. All of these are like this. I want to talk about Hescriot Slope because this is the most bizarre cold seep I've been to date. And I love that none of them are fitting the generalizations. So Hesgrave Slope Mound is 60 meters high, 750 meters in diameter. Michael said, go there. It's shooting out a super flare. You can see the bubbles. It's like 1.5 kilometers long of bubbles. Very cool. Turns out it's not like anything we expected. Methane hydrate is forming in large blocks inside the mound, coming up to the surface, blistering out, actually flowing over the side, and materials are rolling down the side of the mound. They're rolling down and they're accumulating. So we actually saw huge chunks of ice just sliding on the surface. We saw boulders that were round, that were obviously carbonate rocks accumulating along the side. These carbonate rocks created crevices and caves that ended up being the perfect sites for these octopus. We're like, that's incredible. So then we look closer, and the octopus are sitting on eggs, and they're protecting their eggs from crabs and predation. And then we saw babies around them. And I was like, I was really looking for tube worms, but that's okay, because this is also great. So in light of Barry's recent paper, there are some things about these octopus that I'd like to point out. There are a lot fewer than what people have been finding at the hydrothermal vents, like down off South America. Fewer octopus, no heat source, no heat signature. And then, of course, we saw the predation. And I know that there's an octopus expert in the crowd, so please forgive me for making this a cartoon, but we sat there and we documented the mom octopus fending off these crabs. I do have a little video of it. I'll push play. So cold seeps in our waters were designated as ecologically and biologically significant areas because of the chemosynthetic activity they created and the habitat for corals and sponges. Now we have an ecosystem service that we've documented that cold seeps provide, which make them even more valuable. Yeah, I'm not finding somewhere that's easy representative to protect, but what a cool addition to science. And then the last point, the last story of a storyline is seamounts. Seamounts is my bread and butter. My first assignment, model seamounts, ID, representativity. No problem, I got this. I've been to over 20 seamounts in our regions. I have gone to different areas in our region, different depths, different aspects. I've driven in circles because I am so frustrated with seamounts that I circumnavigate them to make sure depth is contained and I can at least plot that maybe the animals like the same depth. No, they refuse to cooperate. So then I found the twin seamounts of the Tuzo Wilsons. This is going to be easy. They're the same biophysical class that we created. They're 4 kilometers apart. They're almost the same depth. Their names are so similar. They're just 1 point away. Surely these seamounts are going to be exactly the same. If nothing else, I can model 2 seamounts. Okay, so we go to NEPDEP 57 first. Absolutely covered in carnivorous sponges. It's barren of sedimentation. It's fine. This is going to be a boring second dive, but at least, you know, we're going to have a replicate. Surely we're going to see carnivorous sponges all over NEPDEP 58. No. Why would there be? It's only 4 kilometers away, the exact same. Full of coral gardens. And there seems to be this super highway of skates just going right past us up to the summit. And it does look like there's eggs all over the seafloor. So I'm like, are you kidding me? If these 2 seamounts can't be the same, what hope is there for me finding representativity? We're just going to have to protect all the seamounts. Don't tempt me, I will. Okay, hypotheses here. The Tusa-Wilson complex, where the big arrow is pointing, is at a triple junction. It's really cool. We had actually identified it as maybe a little bit wackadoo before. It's where the Pacific Explorer and North American plates meet. Okay, so maybe the difference in these places is because NEPDEP 58's active still. Maybe NEPDEP 57's newer and it's founder effect. Maybe they're on different plates, maybe different geology. I don't know. Enter Rachel with a really terrible idea that maybe they're connected. And I'm like, okay, if I couldn't model the seamounts distribution of animals beforehand, I definitely can't do it now. But so I learned about this idea of recharge and discharge, and I think this might be happening. And we know that it happens somewhere else in Canada, baby bear and grizzly bear, and we know that it happens down off Costa Rica. So maybe NEPDEP 58 with all the biology is the discharge, and maybe the recharge is the boring one. There's other information that we found during our dives that gets us to this, and I don't know the answer. So by the time I finish showing you these slides, maybe you won't either, but it'll be fun. So let's go for it. We're traveling up the seamount now. This is NEPDEP 58. We don't know why it's so abundant, but maybe it's a discharge site. There's abundant corals and sponges, and there's skates, and the skates are laying eggs. Why wouldn't they? There's a bunch of skates. Of course, they're laying eggs. And the seafloor is covered in eggs. Not just a couple of eggs, or like in the Galapagos when they found 150 eggs. Our back of the envelope estimates are that there's something to the order of 5 million eggs on this seamount. And then the rocks were yellow. So then we put a temperature probe in it, to which we found there was venting warm water. And then there was more life around the warm water. And then it has nothing to do with anything, but on top of the seamount, there was a whale. And this actually isn't a rare occurrence. We keep finding whale skeletons on the summits of seamounts. Now, if that made no sense to you, it kind of makes no sense to me too, but it's a really fun trip to go on together. And I can't wait to figure out what is happening at NEPDEP 58, but it is not a representative seamount. It is nothing like its twin seamount. And no generalization can capture the complexity of the deep sea. Our seamounts aren't alike, our coral seeps aren't alike, and that is pretty awesome. And so with that, I have this concluding slide. It summarizes everything. You can revisit it. I won't walk through it right now, other than maybe ending with a quote that I really like, that creativity really loves constraints. So if you work within structures, it can provide a lot of really fun adventures in science that you didn't know was going to happen, but you just have to do it with care. You have to think outside of the box. You have to look for those blind spots and then just stay away from generalizing too much when you don't have to. I'll also plug that we're going out to sea again in August for another NEPDEP expedition. And with that, I'll end it with just thanking Hawa, Kleko, merci, and thank you. And it really was fun to run through that with everybody. Thank you, COBRA, for hosting this.